Our quiz 4 solutions for Math 251. You're given the graph of a function g here and asked to sketch the graph of g prime. What I want you to notice here is that this segment right here on the graph g is linear. In other words, the slope is constant. If I were to draw a tangent line anywhere on this segment, the slope of that tangent line would be exactly 1. So therefore, the height of my derivative should be exactly 1 all the way from negative infinity, because there will be an arrow out there. So something like this, all the way until you get to 2. What happens at 2? At 2, I got an open circle. The reason why is there's this sharp turn here, and the derivative is undefined at a sharp turn like this. The reason why is if you define the tangent line as the limit of the secant lines, you put one point right here on the cusp, and the other point can either be to the left or to the right. And if it's to the left, the secant line will look very different than if it's to the right. And so the limits are different from either sides, so the limit that defines the slope of the tangent line does not exist. At any rate, so far my graph looks something like this. Maybe I'll make it a little bit darker so it's a little bit more legible. The height is exactly 1 all the way out here. And we got an open circle at 2. Then what happens? Well, then it shifts into this kind of parabola shape. And so what I got to do is estimate the slope of the tangent line right here. That looks to me, well, it's definitely negative. It's going down. It looks to me to be about -2. There's some leeway in where you put this. My estimate is that it's -2 right here. And then it's getting less and less and less steep, closer and closer to 0 until it gets to 3. And at 3, the height is exactly 0. And then when it moves beyond 3, it starts having a positive slope. And it gets more and more and more positive, which means this goes up and up and up and up. And maybe my graph looks something like this. If you built in some curve here, that's totally fine. Roughly speaking, my derivative is going to look something like this. And I'll even write curved or linear okay for this part right here. Okay, I guess that's about all I have from number 1. Number 2, you're given the derivative of a function and asked questions about the function. That's important. This is not the function right here. I'm not asking you when this thing is increasing. This is the derivative. I'm asking you the function that defines this derivative. When is that thing increasing, concave up, etc.? Okay, so on what intervals is the function f increasing? F is increasing when f prime is positive. So when is f prime positive? Well, look at the picture. When is this above the x-axis? Looks to me to be everywhere from 1 all the way up to 6. I don't want to include 1 or 6 because at both 1 and 6, the function is not increasing. It's flat because the height is 0. And then again, from it looks like 8 up to forever, up to infinity. On those intervals, the derivative is positive, therefore the function is increasing. On what intervals is the function concave up? F is concave up when f prime is increasing. So when is this thing increasing? When is this thing going up? Well, it looks to me like it's going up from negative infinity all the way until it gets to 2. And then again from 3 until it gets to 5. And then again from what, 7 to infinity? So something like that. At what point does the function f have a local maximum? Local max when f prime changes from positive to negative. If f prime is positive, the function is going up. If f prime is negative, the function is going down. If the function used to be going up and now is coming down, in between there I had a local maximum. So let's see, f prime is positive all throughout here and it's negative in here. So it looks like it has a local maximum at x equals 6. At which point or points does the function f have an inflection point? Inflection point, maybe f has inflection points when the second derivative changes sign. So when does that happen? Which happens when f prime changes from increasing, how about increasing / decreasing? So where does that happen? Well, let's see. It's increasing and then it switches to decreasing at 2, it looks like. And then it's decreasing and it switches to increasing at 3. And then it's increasing and switches to decreasing at 5. And then it's decreasing and switches to increasing at 7. Got inflection points at all of those x coordinates. Figure I might as well throw a box around the answers to make it a little bit more clear when you're checking solutions. You don't need this stuff. A little explanation is good, especially if you get the wrong answer. However, what you'll be graded on are these final answers here. Rank these points from least to greatest. I was pretty proud of this question, which probably means you're not going to like it very much. The function, is it higher at x equals 1, 2, 3, 4, 5, 6, or 7? Well, note that from 1 to 6, f is increasing. So f of 1 is less than f of 2, which is less than f of 3, which is less than f of 4, which is less than f of 5, which is less than f of 6. What about f of 7? Where does that play in? Well, that's this point right here. And so from 6 to 7 is decreasing. So what that means is f of 6 is higher than f of 7. From 6 to 7, f is decreasing. So f of 6 is greater than f of 7 because it's going down to get to f of 7. So f of 7 is somewhere in here, less than f of 6. Where is it? Well, I claim it's greater than f of 5. I think it's between f of 5 and f of 6. And the reason why is, think about if you're standing right here at f of 5. On this interval here, f is going up. It's increasing. And at the start, it's increasing really, really, really fast here. So it's going up really steep here at the top. Once it gets past 6, it starts decreasing. But it's never decreasing that fast because this height never gets that far negative. It's never decreasing fast enough to account for how fast it was increasing over here. I don't know. Maybe I'll say final ranking. I got f of 1 is the smallest, then f of 2, then f of 3, then f of 4, then f of 5, then f of 7, and then f of 6. I think that's a pretty tricky question. If f of 0 equals 0.1, how many x-intercepts does f have? Another hard question. I think the answer is going to be 2. And the reason why is, originally, right here, my function is going down. It's decreasing pretty quick. 2 intercepts. 1 shortly after 0. Because at 0, my function is slightly above the axis, but the function is going down, so it's going to cross the axis. It's going down, 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 and then it's going to switch and start going up. And it's going up all the way from 1 to 6. Right? And it's going up this entire... So it did go down a little bit. We're below the axis, but it's going up for so long and so steep that it's going to over-account for all of this stuff. Another... I don't know, near 2? Maybe slightly after 2? Another near 2. Then you might be like, is there going to be another one over here? Because it's decreasing over here. How do I know it doesn't decrease enough to hit the axis? Well, because it was positive for so long, it was increasing for a long time. And it was doing so pretty steep. My function f starts out close to 0, and then it goes down a tiny bit, but then it goes up for so long and so fast that this little bit of decreasing isn't going to get it anywhere near the x-axis. It's only going to have 2 x-intercepts. And I guess that's it. That's the end of this solutions.